So our next speaker is Dick Karp, who, of course, has been with Berkeley, I think, since it was formed back in the Land Grant Act or something, and of course, founded most of what we know as the complexity theory. And I can say as chair, you know, one of the interesting things is when you write up a promotion case, it has to, for those that have joint appointments, it has to go to the other chairs. And I think I have to walk through all of campus since Dick is so well recognized in math and IOR, foundations of computational biology. So 2 years ago, when the Simons Institute threw out this challenge to the international theoretical computer science community, really it was one of mapping the next 10 years or more of the foundations of the field. And it was really a bold statement and stretch. It's not just an institute in a place, but really a vehicle for mobilizing the entire world's theoretical computer science community to come together, tackle the hardest problems out there, and move the whole field forward. So, of course, nobody better than Dick to lead this charge, and a tremendous team behind him with Christos Papadimitriou, Umesh Vazrani, Alistair Sinclair has been pulling a huge effort to pull these things together. It's a tremendous logistical challenge to really do that in the modern age. So we're extremely excited about it, and Dick is going to give us a little picture of what the next 25 years of theoretical computer science will look like from a Berkeley perspective.
Thank you, David. I'm not sure about 25 years. I'm focusing on year one right now. 2 years ago, the Simons Foundation, which was created by Jim Simons, a legendary hedge fund manager who started his career as a mathematician and is very interested in supporting the mathematical sciences, decided to run a competition for creating an institute for the theory of computing at some university. There were 18 major research universities that competed, and we eventually prevailed after a lengthy process. The finalists were a team from MIT and Harvard and a team from the University of Chicago, and Princeton and Stanford were among those that also fell by the wayside. So we opened our doors, figuratively speaking, because we don't have our building yet, but we became operational on July 1st of 2012. What were the reasons for our success in the competition? Well, first of all, as we all know, Berkeley has a very strong array of departments, computer science being and ECS being particularly important, but because of the particular way we view the functioning of the Institute, it's also important to have a supporting cast of many other departments that we can serve. We had a broad vision so that we were not an inward-looking entity looking at core problems that are made up by logicians for logicians, but instead reaching out to application areas in the sciences, engineering, even in the social sciences and in the world of commerce, and looking also at all of the new domains of computation that arise because of the World Wide Web. We're well positioned for ties with industry, being close to Silicon Valley, and one of our responsibilities will be to develop those ties and to integrate people from companies like your own in the activities of the Institute. We developed along the way an enthusiastic following among faculty from many departments. So one of the key moments in our site visit occurred when we had a kind of open meeting where faculty, self-selected faculty from a host of different departments, about 35 different faculty, sort of spoke up about what the Institute would mean to them. And I think that that was pivotal in our being selected. The campus has given us very strong support, as I will detail. And in particular, they've done something quite remarkable. They've made available to us a wonderful building right on the Berkeley campus, right smack in the campus, which will be our home and is currently being converted from biochemistry labs. So it's important, however, that our intention is to serve the world, to be a worldwide center, and each semester in a different set of programs bring the leading figures from around the world, young and old, to participate. Of course, we're going to work on the established core problems of the field, questions of complexity, of algorithm design, of cryptography, of security, questions arising from mathematical logic. But very importantly, we want to develop a kind of new theory of computing that extends far beyond the current reach of the field and encompasses problems that arise in diverse other areas. So the metaphor that we use for this outward-looking view of the theory of computation is the computational lens. And our premise is that many phenomena in the physical, biological, engineering, and social sciences and in the world of commerce can be viewed as essentially computational in nature. So if you look at a cell, how a living cell operates, or how the immune system operates, or the brain, or how a protein interacts with other proteins, we can think of that as basically information processing. Proteins talk to other proteins. There are issues of energy consumption involved. There are problems that are in the domain of physics, but there are also fundamentally problems that are in the domain of information science. If you look at an economy, it's an information processing activity with participants, with many, many agents participating, enabled perhaps by the World Wide Web. And again, we can view this as a computational process. Similarly with social networks, with certain problems in cosmology and the design of experiments and observation in fields like astronomy or geophysics. So there are just many, many areas where phenomena in the field of computation can be viewed through the lens of what we know in theoretical computer science and studied theoretically. This is a theme, this is a point of view that really was nurtured here in Berkeley, and as early as 2002, to commemorate a grant that we were given in this direction from NSF, we held a conference where people were brought together to explore this computational lens idea as it applies to many areas: quantum information science, statistical physics, social networks, and so forth. And we replicated this thing with an up-to-date conference in a similar vein in 2011. So this computational lens will be a recurrent theme in the activities of the Institute over the years. So here are a few examples of scientific questions that can be studied that are fundamentally related to the sciences, but also to information science. Will the effort to understand the limits of quantum computing lead to a major revision of quantum mechanics? So as we attempt to build quantum computers, we will have to cope with the fundamental phenomenon of entanglement that distinguishes quantum computing from classical computing. And we will have to test systems that are more complicated than physicists have ever studied before. Will the theory of quantum mechanics hold up, or will we find that a revision of quantum mechanics is required? As we look at markets that are enabled by the World Wide Web and the Internet, with huge numbers of agents competing, cooperating, interacting, bidding for goods, et cetera, offering goods, we get very complicated interactive systems which can be viewed as computational processes and require a sort of much more detailed and large-scale analysis than is typically made in economic theory. So we will need a new nano-economics, and one of the issues will be whether the computation of the behavior of these systems is actually tractable. Can we predict the effects of our economic choices? Biological phenomena at all scales, from evolution down to the living cell, are inherently computational in nature, and this is an important breeding ground for computational models, especially at Berkeley, where we have a thriving center for computational biology. In statistical physics, statistical physics studies the phenomena that occur where you have large numbers of interacting particles, atoms, electrons, spins, and so forth, and very often uses probabilistic methods. It turns out that the probabilistic methods used in statistical physics and the problems that arise in that area are almost isomorphic to problems that arise in the theory of computation having to do with constraint satisfaction problems like the famous Boolean satisfiability problem. And there are all kinds of exchanges of technique and information between the realm of statistical physics and the realm of theory of computing. So let me tell you a little bit about how we operate, how we intend to operate. We will be running, the Institute will be a kind of revolving door in the sense that there will be very few permanent staff and mostly, by a large measure, groups that come through to spend a semester or in some cases an academic year at the Institute. And in each semester, once we reach steady state, the Institute will focus on 2 particular programs that will be explored at that time. Because our building isn't ready, we will only start operating at full scale in the fall semester of 2013. So we'll have some rather restricted activities in this coming spring semester. Most interestingly, we'll have a symposium on visions of the theory of computing, and I'll tell you a bit more about that in a moment. And we'll also run an exploratory meeting on quantum Hamiltonian complexity. But then every semester after that, we'll have 2 programs, and let me just say a few words about the first few programs. So the program on real analysis and computer science is based on the fact that methods from mathematical analysis, which don't seem at first sight to have much to do with the discrete structures that occur in computation, actually can tell you a lot about computation. And this connection with mathematical analysis will be followed up in this first program, which develops tools that have applications in hardness of approximation, communication complexity, theories of social choice, and other areas. The second program, the counterpart of that, will be a program on theoretical foundations of big data analysis. This is perhaps our most popular program, at least in terms of the number of inquiries we get, because big data is so much on everybody's screen right now. And this program will deal with how we can soup up machine learning and inference mechanisms to deal with the very, very large data sets that are now emerging, how we can deal with minimizing the erroneous inferences that we make when we're dealing with heterogeneous data sets and uncontrolled sampling of data, and to do all of this with low computational complexity. So this will be a mix of statistics and algorithmics. In the spring of 2014, we'll be bringing together computer scientists with evolutionary biologists, physicists, and statisticians to understand developments in population genomics and take another look at the theory of evolution, modern theories of evolution, much more detailed than those that Charles Darwin ever thought about. And the last program that I'll talk about in the spring of 2014 is a somewhat specialized program in the area related to quantum computing but in particular looking at the computation of the equilibrium states of natural quantum systems. And in general, what we do is program about 2 years ahead and have a diversity of topics ranging from the inner core of the theory of computing to outreach to diverse areas. So the main event of this present semester is a symposium on visions for the theory of computing that will be taking place here on campus May 29th to 31st. We've got an all-star collection of speakers. I think you'll recognize some of the names, and these people cover everything from the flocking of birds to genomics to neuroscience to complexity theory to social networks to the cloud to artificial intelligence, quantum computing, statistics, economics, and nanoscience. So it'll be a diverse collection of visions from all of those directions about where the theory of computing can be expected to go. No answers for the next 25 years, but at least some points of view. We've been granted substantial resources. The Simons Foundation will give us $6 million a year for 10 years, and with a prospect of a continual endowment after that, but we will also be looking for other funding sources. The campus has been very generous with us. A key moment came when we discovered that the campus was willing to allocate Calvin Hall, a wonderful round building that reaches out in all directions, nestled between the law school and the business school, which is currently being renovated. So we're learning a lot more about tile flooring and lighting systems than I ever expected to have to know, but we're making progress on renovating the building. It'll be ready around the beginning of June. The campus has allocated 2 senior scientist positions. These will be professors who have permanent positions, half-time in the institute and half-time in departments. We're currently searching to fill the first of these positions, and the department in that case will be EECS. And then we're given additional resources to allow faculty to participate in the programs. And very importantly, there will be, in addition to the 2 senior scientists, 7 additional appointments over the decade in areas relevant to the Institute, but they could be in anything from cognitive science to material science, which will be underwritten by the campus to sort of round out the kinds of things that the Institute can do. We've already hired an outstanding young theoretician, Prasad Raghavendra, and as I say, we have the 2 senior scientist positions, which should contribute to the department's resources. So, as I said, our scientific activities will be based around semester-long programs, typically 2 per semester. We are conducting a worldwide solicitation for program proposals. Our associate director, Alistair Sinclair, is particularly productive in working with proposers to round out their proposals and bring them up to a level where we can agree on funding them. We have a strong scientific advisory board. We're trying to program 1.5 to 2 years in advance to have plenty of lead time for running the programs. Each program, there'll be 2, as I say, 2 per semester, so we'll have about 70 visitors cycling through of different levels of seniority. We'll have 3 to 5 in a single program, 3 to 5 program organizers, 6 to 10 visiting and Berkeley faculty, 6 to 10 postdocs, and a number of visiting and Berkeley graduate students. So these postdocs, we actually call them fellows because their term of appointment is typically a semester, which is a little shorter than the usual postdoc. We call them fellows, and we've just been in the process of sifting through applications for this coming year, and we've got I think, a very distinguished group of fellows who will be joining us. And then each program will have several week-long workshops which will attract an additional influx of visitors to the Institute. And our policy is to be open to anyone who's interested in coming to our workshops or interacting, and also an open intellectual property policy to prevent any difficulties in propagating our scientific results. So a program will typically start with what we call a boot camp, referred to here as a summer or a winter school, to bring people up to speed about whatever the topic of the program is. There'll be 3 week-long program workshops in the course of the semester, various seminars and public talks, and then a year after the program we'll have a retrospective meeting, and one of the products of the program will be a white paper which will sort of inform the field about the status of the activity that underlies the program and could be the basis for funding by various federal agencies. We will also run occasional symposia that will have broad appeal, so a general scientific public will be drawn to it. I particularly invite you to come to the Visions of the Theory of Computing Symposium. And we'll have other activities. For example, one of the leading theory conferences is the Fox Conference, and we've arranged the IEEE Fox Conference, and we've arranged to host that every other year. Also, we are very aware of our responsibility to the campus. Although we're reaching out to the world, we also want to strengthen the campus. And so they're associated with every program. There will also be a graduate level course on the theme of the program that will be taught and available to our students. Now, what about the impact on faculty hiring? Well, since the 3 scientific leaders of the Institute, Alastair Sinclair, Christos Papadimitriou, and I have been relieved of most of our teaching responsibilities, we will have a little bit of a shortfall in teaching immediately, but with the 2 senior scientist positions and the other appointments that are coming down the pike, we think that the effect of the Institute will actually be to enrich the curricula on campus as well as serving the worldwide community. As I said, in the course of the decade, there will be a total of 10 campus positions in areas closely related to the themes of the Institute. These will not all come in EECS by any means. They'll be spread among a number of departments. Now, one thing that I want to bring up is that while I spoke earlier of outreach to various scientific fields, there are many areas within EECS that are prime targets for the creation of programs. And I list some of these here. You can see image processing, robotics, communication theory, et cetera. All of these are areas that are highly active in the department and also really dependent on algorithmic techniques and theoretical approaches to information processing. So we will explore these. For example, we're contemplating a program in information theory. We're developing a program in security for a future year. We're running a workshop on differential privacy. We're looking into neuroscience. Machine learning is an underpinning of our big data program, and big data and machine learning will recurrently come up as activities of the Institute. So these are just examples of areas which are crucial to the department and also will be in time fostered by the Institute. So over the course of a graduate student's career, they'll have a choice of about 20 programs that they can interact with, and we think that virtually every graduate student will be enriched by the presence of the Institute. So let me just show you a few images of Calvin Hall. This is the way the building looks right now. Here are some visions of the way it's going to look after the renovation. We're going to have, this is the reception space for the new auditorium that we're building. The next few slides show our vision of the interaction spaces where people will gather for coffee and informal interaction. You might notice Jerry Seinfeld is down there on the lower left. So I think we're going to have very beautiful spaces. And finally, let me just say that we're very interested in reaching out to the community at a number of levels. We hope to hold public events of cultural interest to the local community. The first one of those was held last fall jointly with the Mathematical Sciences Research Institute, and we featured Andrew Hodges, who had written the the seminal biography of Alan Turing, and he came and told us about Turing's life. We also want to have a rich set of educational activities dealing with aspiring teachers in mathematics and computer science and K through 12 education. The Mathematical Sciences Research Institute does a lot of this, and we'll be a partner with them in some of their activities. Jim Simons, the founder of the Simons Foundation, is also the founder of a program called Math for America that motivates bright young mathematicians to spend some time teaching in high schools, and we'll seek interaction with that. And we very much want to enhance our collaboration with industry. We already have formal ties with Google and Microsoft India, but we're looking for a rich fabric of connections with people such as yourselves who will be invited to the Institute, and we'll have partnering arrangements where people from industry will be able to visit. They'll be informed about lectures and other activities. They'll be brought in contact with graduating students and so on. And so if you want to look into that, please contact us. And you can talk to our wonderful managing director, Kristen Kane, who's handling so much of the load as we get off the ground, along with Alistair Sinclair, who's done vast amounts of useful work for us. And I invite you to take a look at our website, simons.berkeley.edu. So thank you very much. I'll be happy to take questions. Questions?
Question or two for Dick Karp. One way in the back there. If you want to scream it out, I'll try to repeat it.
This looks incredibly exciting, and I have a daughter who's thinking about applying to college this year. I'm wondering what sort of undergraduate opportunities there are in this institute.
What sort of undergraduate opportunities are there?
Just to do some semester time research on undergraduate research.
Yeah, well, as faculty, we're all open to running projects with undergraduates, and each of us at the Institute, the few of us who are primarily at the Institute, will certainly be open to that. In fact, I'm looking for an undergraduate to try out some algorithms that I don't know enough about programming to do myself. But it won't be primarily an undergraduate operation. It will be focused on research. However, in connection with the outreach to K through 12 and to bright young science students, we will be having some activities.
So I can say as part of this process in getting here, it was full of amazing moments. I think one that struck me was in practice talks where we had 2 vice chancellors and 3 deans in the room and critiquing Turing Award winners give their practice talks, and then the realization, oh my gosh, this is really a new science that you're driving. So obviously we're very fortunate to have the team we have, and I think you can see that we're off to an exciting, considerably long effort to advance the theory and its connections to the broader world. So, Dick, thank you.
Thank you.